All right, so go ahead and get out your notebook and a piece of paper and start to copy this down with me. We're gonna reinforce what we talked about, what you guys started figuring out on your own about intensive properties and extensive properties. And just as an FYI, I got many messages about the Google Jamboard and it not being clear about what we had to do. I decided I'm not going to grade that day. I'm going to give those of you that did it extra credit. So if you did it, good for you. You get some extra credit. Otherwise, guys, don't worry about it. I'm going to clear up those misconceptions today. Okay, so first and foremost, what we need to ask first is, are these properties determined without changing the identity of the substance? Now, meaning without changing is your key words here. Because remember, chemical properties involve some kind of change that reacts with those key words. Remember when we made that chart? If not, go back to that chart where we distinguish between physical and chemical properties. So if this is a no, meaning, because remember it says, I'm going to switch this over to the side a little bit. So without changing the substance, this would be, if not, these would be chemical properties, because remember, these do change the identity of the substance. Okay, so that's chemical properties. But if the answer is yes to that question, oh gosh, sorry, balancing a few things here. But if the answer is yes to that question, let me see here. If the answer is yes, then these would be considered physical properties. Now, intensive and extensive properties, guys, are subcategories of physical properties, meaning they can be divided in from physical properties. And hopefully for those of you that like these kind of maps, it makes a little bit more sense. So first and foremost, we have, and I'm going to try to make this, sorry, I'm kind of balancing a camera at home here. So we have intensive, let's talk about intensive properties. So this is what you should have seen on Friday. So key point here, guys, is that intensive properties do not depend on the amount of matter. So what does that mean? When if I have a cup of water here, I have a cup of water, and I decided to pour like half of that water into another cup of water. The proper intensive properties do not matter. It stays the same. So for example, these are the examples of intensive property. Color, taste. Would water still taste the same if I poured it into another cup? Yes, it would. The melting point of water and the boiling point of water would still be the same, right? No matter what, the boiling point of water is 100 degrees Celsius. That wouldn't change even if I have less of the matter, even if I change the matter in some way. Density, I'm going to keep going down here. Density, luster, remember what that word means again, otherwise known as shininess. Is it shiny with an I or Y? Whatever. And then hardness. These are all examples of intensive properties because the amount of matter doesn't affect them. They stay the same. Okay. Now, let's talk about extensive properties. And that's what we will be using this chart to make a Venn diagram today. So let's talk about extensive properties. They do depend on the amount of matter. They do change. Therefore, are they reliable? as reliable? Probably not when it comes to identifying, meaning giving a name to the substance, okay, of matter. So these include mass. If I poured that water out, would the mass change? Yes, it would. So it does depend on how much matter is present. Volume. Would the volume change? Yes, it would. Length and shape. Okay, so mass, let's look at the technical definitions of each of these. Mass is the amount, or how much, the amount of matter present, meaning the amount of stuff is what I like to call it. And then we have how much space gets taken is volume. Length, obviously, we think of like a ruler or a meter stick. And then shape is straightforward. Okay, so I like to use this map to kind of organize everything we've talked about. So these are all properties of matter. Changes of matter would be a whole other thing. But this is how intensive and extensive comes into play with all of the properties we've talked about. Now, what you are going to do today, you are going to open that Word document that we talked about, the Venn diagram that was mentioned in that other video. Sorry, I tried to make sure to point out to follow the directions on the day's classwork and not the video, but I understand the confusion. So you're going to open up a Word document that has a Venn diagram. Okay. So just based on that chart we just talked about, I want you to think about the similarities and the differences between intensive and extensive properties. So I think I don't remember how I laid it out, but intensive and just pay attention to how I labeled them. So I want you to tell me, try to think of at least 3 similarities. So these would be the differences, right? If they're laid out, well, I guess the bullet points would go there, wouldn't it? Think about the differences that would go in these circles and try to think of some similarities. This might be hard, but think hard about, look at the chart here. What is the most obvious similarity? These are both what properties? These are both what kind of properties though? And then tell me more about that. Okay. And then I told you guys to lay down the examples of each, which we just talked about. And I want you to give me the definitions of each of those examples. Don't know the definitions? Look up the definitions. Okay. When you're done, you're going to resubmit it on Canvas, but feel free to email me with your questions. Hope that helps, guys.